is wrong. Okay, it's degrees Fahrenheit. At 650 degrees Fahrenheit, the oxidization seems to be much higher than at 700 degrees Fahrenheit and even above. So I'm going to try once again the SnCx alloy. I'm talking about the SnCx alloy here. So I'm going to try the test once more at 650 degrees and leave it for 1 minute onto the soldering iron tip. So let's clean our tip. Feed a good blob of solder there and wait for a minute. Yes, at 606 degrees Fahrenheit it seems the oxidization is quite large. Now I'm going to do the same test again at 700 degrees Fahrenheit to see how it goes. So I clean the soldering iron. I fed a nearly equal amount of solder blob onto it of SnCxPlus07 and back in a minute. So here it is after a minute at 700 degrees Fahrenheit. The SnCxPlus07, no signs of oxidization, no significant at least. That's very interesting. It seems this alloy doesn't like the 650 degrees Fahrenheit temperature. I'm going to do the same test again with 600 degrees Fahrenheit to see how it behaves. Again, a good blob of solder onto it, about the same quantity as before, but I first have to reduce the temperature to 600 degrees and wait for the tip to cool down. Okay, the tip is cooled down at 600 degrees Fahrenheit. So I'm do the test now again, about 1 minute. Okay, so here it is. No significant oxidization. There is some, but barely seen in the camera, I guess. Okay, so that's very interesting because it seems this alloy, this particular alloy, doesn't like the 650 degrees Fahrenheit at all. So the best temperatures to hand solder is between 600 degrees and 700 degrees or something like that, and not around the 650 degrees Fahrenheit. Interesting observation. So now I'm going to do some hand soldering of a few leads of wires to see how they behave in the different temperatures. But before I do that, you have to understand that this test is done onto a hot soldering tip for 1 minute at different temperatures. So it's actually the worst case scenario you will encounter when you solder by hand the different components and leads. The situation may be different probably, so we'll see that in a minute. Okay, here we are. I have bent a few components leads. These are tin plated lead free, I think, ROHS, and I'm going to try first the SnCxPlus07 alloy at 600 degrees Fahrenheit. I'm going to try to solder. It will be difficult to show that at the same time I'm soldering, so let me readjust the camera a bit. So at 600 degrees I'm doing the first joint. Yeah, it seems okay. That's the joint we just did. Seems clean and as shiny as the SAC alloy. I'm gonna clean the tip and do it again with the SAC305 alloy. Here it is. No, it can't focus. I'll try to hold it that way. Here it is. It seems as shiny as this one. So the soldering is similar at this temperature. Now I'm going to increase the temperature to 650 degrees Fahrenheit and do the same test again. on another joint. Yep, temperature is set. Let's do this joint. Here it is. Come on, focus. Here it is. Okay, again. Let's try the same with a SAC alloy. Here's the same with the SAC alloy. Here is with the SnCx alloy. Similar results, I guess. Yeah. The SAC alloy is a little bit more shiny, a little bit, just a little bit, barely noticed. Now, let's do the same at 700 degrees Fahrenheit. Another joint with the SnCx alloy. That's the SnCx alloy, and I'm going to do the same with a SAC alloy. Let's focus it a bit clearer. Okay, so here it is. This is the SnCx, the SAC alloy, and this is the SnCx alloy. They seem quite the same. Actually, I can barely notice the SnCx alloy to be a little bit brighter and shinier than the SAC alloy, but that's barely noticed. Okay. So what I'm going to try next is to put a little bit of a few solder blobs onto a piece of copper clad board. I'm going to use the 700 degrees here, as the surface that has to be heated is much greater. I'll give it a good clean with the SAC alloy, and I'm doing the first that's with the SAC alloy. And at 700 degrees Fahrenheit again, I'm going to try the SnCx alloy, give it a good clean. Now, let's see the difference. Here they are. At the right hand side is the SAC alloy, and at the left hand side, sorry, is the SAC alloy, and at the right hand side is the SnCx alloy. If you see the SAC alloy, it's shiny. Both are shiny actually. The SAC alloy shows a few signs of I don't know if you can see it well. I'm trying to refocus the camera. The SAC alloy is not so shiny at the very, very tip of the blob, whereas the SnCx alloy is shiny right up to the top. Let's see that in the other side as well. You see, that's the SAC alloy, which is not so shiny at this point. You see that point? It's not shiny there. And this is the SnCx alloy, which is shiny throughout the whole surface. This thing you see here is just a small hole in the alloy. This is not an unshiny point. Okay, so this is shiny throughout the whole surface, whereas the SAC alloy shows a little bit of, it's a little bit unshiny at the very top. And I have verified this in many other tests, so it's not the first time I'm doing this. Now I'm going to try another temperature. I'm going to try an 800 degree.